Well, ladies and gentlemen, let's move on with area graphs in Python and in Dash. On my website, you can find a lot of detailed information regarding code to make area plots, like this one, for instance, here. And I've also used Plotly, the quite nice visualizations you get that are much more interactive. So I'm not going to talk through all of this because that would make this a very long video, and it's all there on the website. So you can figure it out yourself. So I'd recommend that you walk through this and you try to follow these steps. It all depends a little bit on your data set, of course. You can use mine to practice with. There is a link here to the CSV file, so you could use that one also. But if you got your own data files, I'm going to use another one actually now in my example because it doesn't necessarily have to have this structure. After downloading the data, which looks from the websites that I refer to, looks a bit like this, where you get your regions here as one column and years as a column, and then different columns with information regarding CO2 emissions from fossil fuels and cement production in total, and then split up into solid fuel consumption and liquid fuel, etc., down to per capita emissions. So that's per person. So what I've done initially, I went to this website here, and if you download this data set, the entire data set, then it would look like this here. So you can open it up in Google Sheets or in Excel. And the only thing I've done here is to remove these three first rows because they don't contain essential information and they would mess up our CSV file. So I've downloaded this and then I've put that on my GitHub site. Let's see. It's this one here. And you can see that those three rows have been deleted, but all of the other information is still there. So this looks quite different from the same data set that I've manipulated in Google Sheets. I made a pivot table, etc., where you have all the regions here as columns and years there in one column. So this looks quite different, as you can see. So you got the regions in one column. So it could well be that your database is also set up like this, but you can work with this in Python straight away. So let's have a look. This one here. I need to go to this one. So this is the link to that same so this link here is the one I'm using as my URL. And if I read that data, let's have a look. Zoom. And there we go. Then I see that I've got same setup as a table. The only thing I've done is that I have queried. You can see the syntax here. I've created another data frame based on the original data frame. So this data frame here is a subset where I've said I only want to see the years that are bigger or equal to 1950. So I've made the index column the year, so that's why I'm here writing df index bigger than 1950. And the reason for that is that here in this column, the last one, there is no data until you get to, there we go, until you get to 1950 there. That's the value there, 1950. So I've excluded the first initial years for that particular reason. I'll explain a little bit more later why in particular, because I want to plot all of these different columns eventually. So that's my data frame. Now, then what I did here, let's see, is if I were to plot this, and I'm now plotting the per capita CO2 emissions because I ran into an issue. I just want to show you how I solved it. I ran into an issue with that last column there, this column here. There's a decimal point. In contrast to the other columns, they don't have decimal points. So if I were to plot this, then I get a very peculiar plot. Takes its time. But here it is. Yeah. So I was supposed to. And so my column that I'm looking at is this per capita CO2 emissions. This is just a column map for the colors. But I was looking at the x-axis here is supposed to be the years. You see the index column, which was years, and the y values is that column that I've indicated. And what I get then is something that doesn't make much sense. Look here, the y-axis is 0, 5,000, 10,000 for the years, which is meaningless. And I struggled with that. It took me an hour almost to figure out. But what I discovered was that if I look at the info here for this particular data frame, there I can see that all of these columns there are integers, apart from the region as an object, because it's a list of strings. And the last one here is also an object. Here, per capita emissions has been, yeah, you might say misinterpreted, and that's because most likely that decimal point is in there. So you might as well run into the same issue. So what I, after some searching, found out was that you can change a column. So I've indicated the column here. You can change that to a numeric value. See, PD to numeric, and there I've indicated that same column. So if I run that and then ask for the info again for this frame, you see now it has become, instead of an object there, it has become a so-called float 64. Not an integer because it has a decimal point, but a floating number, so it can have decimal points. And if I run the code now again to plot the graph, you can see that it actually looks like something more meaningful. We actually have years here in the bottom. So that was one of the first issues I ran into, and I wanted to share that with you, just in case. Now I can change the column to something else. I can say, okay, I want the total CO2 emissions, for instance. There, I'll copy and paste that. Control C into my column here. Zoom there. Control V, and then I run this again. And now you'll see that you get a different data basically. Yeah? Different title also. Okay, wonderful. So that was one thing. Then the syntax, by the way, for this one is simply px bar. Yeah, you can also change this to area. Let's have a look. And if we do area, we get something very similar, but now it's more a line graph with filled in areas. It's stacked, by the way. So all these values are on top of each other, so we don't get the lines. Let's try, if I just do line here. Let's see if that works. And indeed, yeah, so here now you see it's no longer stacked, all the lines run through each other, so you get a different type of graph. Let's go back to area, and nice. All right, now I wanted to make a pie chart also, and for the pie chart what I wanted to do was to select a number of years. So I have gone with a range from 1960. I've said, okay, this variable is 1960 and this variable is 2000. So now I've selected here first all the values that are below this max year, below 2000, and then all the values that are above the min year. And then if you look at the DF range now, it should be between 1916 and 2000. And that's indeed the case. You see 1960 here for Africa, and it ends with the last region, Western Europe, and ends with 2000. So that's very neat. Now, in order to make a pie chart, I need to have totals for all those years. So this expression here, I've created a new database called a data frame, I should say. I should not say database, data frame, which I've named summation of. So I've looked at the range data frame that I just created, and I used a group by expression. So group by means that it's going to group all of the rows looking at the regions. So I've indicated here which column it needs to look at. And for every row that has a similar expression in that particular column for regions, it's going to group them and calculate the sum there. So let's have a look at what it looks like. I said numeric only. So if there were to be other values in those columns, it's not like strings, for instance, it's not going to do anything with them. And here you can see now that I have, first of all, it's created a new index column here. The years have dropped off. But we see here totals for all those columns. Yeah, so that's very nice. So take note of the syntax. Then I wanted to make a pie chart. So what goes into a pie chart? We need to indicate which data frame we're looking at. We want to indicate which column it needs to look at. So in this case, again, I've gone with the per capita emissions, but it could be any other of the other columns also. And for the names, I want to have the names of the regions. And in this case, because it has become the index column, I can use the expression df range sum index. Otherwise, I would have to write region here if region was not the index. For the colors, I've used the same column of region, so it's going to give every region a different color, and I've indicated which color scheme it should use, and this is red to blue, I believe, RDBU. But you can, if you Google PX Plotly colors sequential, I'm sure you can find other expressions. So you could change this to another value of your liking. Labels, that is for the labeling of the pie chart. Title here, I have indicated also which years we're looking at. So I've made a syntax here where I want to have the column, that's the per capita CO2 emissions, and then from, and this gives me the year, minimum year and maximum year. And then I need to say that the title of the text needs to be that particular title. Let's have a look if that works. Yeah, there we go. I know it's going to work because I've did this before, of course. And make no mistake, I had to, there were errors in my syntax also, you know, so you're going to have to probably fix things up a little bit according to your error messages that you get. And of course, also all of the syntax, I don't make it up on the spot either. I go to the Plotly website, yeah, so Plotly, and then I look at pie chart, yeah, and then there is here enough, and there's some different codes that you could use here. So here you see an example, and of course I worked with this also. I manipulated a little bit myself, but there is various examples here that you can work with. Okay, let's go back down. The last thing I've done was to create a box plot. So that's simply saying box. And I've done the same thing. No, I've used the range here. So we're looking at 1960 to 2000 here. And you need to have a range. You can't use the summation like in the pie chart, because for a box plot you need to have minimum, maximum, etc. So it needs a range of data for a meaningful box plot. The x values going to be the different regions. So we're going to see a box plot for each particular region. And the column, I'm using the same column as here before, because I defined this variable already there in that cell. I can use it here again. Color is based again on region, and I'm using the same color set there also. And what else did I do? Updated the title for the y-axis title. Yeah, you'll see what it looks like here. So the y-axis title, see that is the same as what we see in the top there also, but there's some freedom there. You see from 1960 to 2000, so it's done that nicely, and we get a legend here also with it, so you can exclude, for instance, I can get rid of Africa, and you see how it updates the graph accordingly. And if you go over it, you can see the minimum and maximum and the quartiles there also. Now, wonderful. Now, with Dash, and that's next thing, that's a more interesting thing really to look at, and you can see an example here on my website also. Dash is an extra library added to that we can import into Python, and that it's working on top of Plotly. And with Dash, what we can do is make plots like this. So here I've got an example of two graphs. One is a line plot and one is a stacked area plot. And you see here in the top, I've started with North America, but I can add, there's a drop-down box there, I can add other regions. And if I do that, you'll see that both graphs are updated with that information here. So I can add and also, and now you see another region added to it, and I can also take away. So that's really nice. So it gives the user a lot of freedom there to play around with the data and display. You can display several graphs here that will be updated according to your drop-down box. This is a drop-down box. In this lesson, I'm going to also create a slider, and I wanted to combine all of these graphs here into one dashboard instead of having individual graphs. So they're all going to be connected. And what that looks like is this. And the codes will be available for you on my GitHub page. So just follow a little bit through as I talk through it. We're going to have to use not just Plotly as before, but also Dash and Dash core components and Dash HTML components and Dash dependencies for input and output for the drop-down box. Drop-down box has an input and an output value. And of course, pandas as PD. External style sheets, that is just a CSS file that defines some of the HTML components in terms of what they will look like. Then here we got the same URL. I'm basically doing the same thing here as that I did before in the other script. So I define again, I'm starting off with a max and minimum year, 1950 to 2014. That's the last year that I have. I'm creating the initial ranges there based on that, yeah. I'm initializing already the data frame, because once we start to build our drop-down box, I am going to use some of those values from those data frames. Now, building an app, you first need to define it. So your app is going to be based on that dash library. So it's a dash.dash, and then you can enter a few parameters. These are two quite common ones. First name, and then external style sheets. That's the external style sheets that were defined here. So it's going to use that HTML style sheet. Then you need to define a layout, and that is based on HTML divisors. So I'm going to create different containers with different elements. This container here, first of all, it has a title there. H3 refers to the size, so you can change this to H1, H2, H3, H4, up to 6, I believe, and it determines the size of your title. And I've entered just a string there. Then, second division is going to be my drop-down box, and that is defined in a way that's also, if you go to, now you have to go to dash, of course, dash drop down, then you can see, zip, here you can see some of the examples. So default drop down. So here I've basically copied this, so you don't have to reinvent the wheel. It's all there. So here are some examples also. In this case, you'll see that there is a choice of 3 cities. These have been hard coded into the drop down box, but I want to find a drop down box with values from my data frame. So instead of hard coding them, I have said give it a label there with values based on, for C in, the range of the sum of the columns. So in this data frame range sum columns, if you remember well here, let's see if I can quickly show you again as a reminder. I've gone past it now. Here, was the data frame range sum. All of the columns here are the ones that I want in my drop-down box. So what I want to achieve is that people can choose between the different columns for their graphs. So that is what this expression here. This is a listing of those columns. So all my labels are going to be based on those headers in those columns. Style display, this just gives a bit of an indication. You can play around with the percentages, and yeah, it's based on HTML style sheets. Now, then what I wanted to do is I want to give people an option to choose a range of years. So I have also indicated a range slider, and once again the range slider, what it does is, you can see here, this is a slider that allows you to choose between years. In this case, this example is based on something else. There's a minimum of 0 to 20, and so if I go all the way to the left, that would be 0, all the way to the right would be 20. So in my case, I want to base it on the years initially, the minimum and maximum years there, which I've indicated there. Yeah, so that's I've initialized them as 2014 and 1950. Step is 1, that means that it's going to jump from one year to the next year, no intermediate values, and these are the starting values. So indeed I said let them be 1950 to 2014 there. You can also type it in there, hard type it, but I didn't do that. I based it on the variables. Now then you've got here another div with a first graph, and that has an ID to it, graph 1, graph 2, and graph 3. Those are the 3 graphs that I just showed you. So it's a stacked area, pie chart, and the box plot. I'm going to have to define them still here, so that happens here. Actually, I've created a function that is based on 2 parameters. I'll explain to that later. But basically what happens here is that I'm going to pull out my minimum maximum year based on the slider. I'll explain later how this works a little bit. And then basically I'm going to again query my data frame, the original data frame that I had, the big that had all of the data. So again, I'm going to now reduce it between 19 whatever value people choose, let's say, a minimum and maximum year. The range of the sum, that's the same thing. That's for the pie charts. And here I'm going to define my first graph. So that's an area graph. That's a stacked area. Same definition as before here. Title is the same. This is all based on what I did before already. And same here. Nothing changes really here in terms of creating these figures. The only thing that's going to be influenced each time that a person chooses a different setting is going to be which column are we looking at and which year values are we looking at. And that's applied here to the definition of the querying of the data frames. Now this definition, this function here that's defined here, this function is called create graphs. That's a name I just came up with myself. It could be any name. And this returns 3 figures, fig1, fig2, and fig3. And they refer to those names there, yeah? So fig1, fig2, the pie chart, and fig3, the box plot. All right. Now here you see this expression app callback. And a callback is a function that will kick in as soon as somebody changes a different value from the drop-down box or from the slider. In this case, it's from the slider. So this here refers, you see here, input my range slider, output container range slider. This refers to the slider that was defined here. You see ID my range slider, and the output is there. So now in a similar way, I've done that for the graph. So this is based on the idea that people choose a different value from the columns. So the graph that I've defined here, graph 1, that one there, yeah, is related to a figure that's going to be plotted, and the values that are going into this callback are the column value, that's the drop-down box, and the slider value. I'll share the script with you so you can use it also. I must say, once again, it took me the greater part of a whole day to figure this out. So I had some sample code here and there, but I had to mess around a lot before it actually got to work. Then I've created another function that will be applied when this callback happens. So this thing here is executed the moment that these callbacks will be triggered by an action that the user takes, meaning choosing a different value from the column. Now, this definition, this has two parameters here, and basically it will then execute that function create graphs that I defined earlier on. Last thing is here, run app. So if the name of the app is main, that's a general code, then app run on the server. So let's run this and hope for the best. I'm gonna stop the kernel, restart and run all. Now, let's see what happens. Once it's executed, you will get this message here. Dash is running on, and this is a local server. And what we see is, there we go. Took a little bit of time. Again, what we see is the free graphs that we defined before. With the initial value here of the total CO2 emissions. That's my starting value. I didn't explain this before, but in my columns here, this is the drop-down definition, I gave it the value of the first column there. So that's a starting value. So that's where it initially starts off with. But then I can now open this Dropbox and I see all the other columns are there also. So I'll go to this one, emissions from solid fuel consumption, and you'll see that here the title has changed. I'll do it again to make it a bit more clear. See, both the pie chart and the graph change, and it's difficult to show that in one go, but this one here, it says here distribution of emissions from cement production per region. That is linked. If I choose solid fuel production, fuel consumption, then you see it's changed also. Also the box plot is changed accordingly. Great. Yeah. Now the sliders, let's see if they work. I'll pick this one up and let's see. Yeah. So you can clearly see the stacked chart is now running from 1980, 1979 to be exact. You see here in the title, 1979. And I can reduce it also, and now it's showing it to 1996. A bit annoying that this pops up there, but that's a bit standard. Maybe you can hide that actually if you would want to. And also you see the pie chart changes. Let's do that again. Let's make it a bit bigger. See, the pie chart is recalculated because now I've got a broader range of years, and that means also that the percentages will change accordingly. Great. Yeah. The only thing is, this runs locally, and if I wanted to share this online, then I need to take some additional actions. So how does that work? And this also took me some time to figure out, but there's an easy way to do it. There's a couple of difficult ways to do it, but an easier way is to use a provider called Heroku, heroku.com, and that looks like this. And I'm running already 2 applications. They provide a free service up to 5 applications. So we can work with this as a free user, but then it limits it to 5. So once you got 5, then you can no longer add other ones. I can show you, for instance, here, this is the app that I've already deployed. So this is the one that's on my website. So the one you saw before. So this runs here on a server from Heroku. So how is that achieved? And for this, you'll need to use your GitHub. Let's go back here to the basic page. You'll need to use your GitHub repositories. So basically, what you need to do is, and I've also explained this, by the way, to a certain extent on my website here. So there is all of this information what you need to do here is also written down here. It's mentioned Heroku here, but I'm going to show you anyhow because it's not so simple necessarily. First, you want to go to your repositories if you have them already and create a new repository. New. So I'll give this a name. This is testing. Now let's give it a more reasonable name. Carbon emissions dash slider. Let's call it slider. Yeah. No, I'll create this one. I'll leave the standard settings. Create repository, and then you get some general information there. Get started by creating a new file. So I want to create a new file. Name the file. Now in this case, I would recommend you call it app.py. And py refers to a Python script. Note the difference, by the way. So this is the script I'm going to run. Note the difference. So I'm going to copy all this. Copy that into the file here. There. The only thing you need to add is here. You need to indicate what the server name is. Here, my repository on GitHub. Look at the sample. So you got a link to this. You can always look here also. Let's look at this this script here. You'll see that here. Oh yeah, this is the code. Server equals app server. Control C. So I'm going to add that to this file also. Server equals app server. And then I'm going to save it. That's done here. Commit new file. So that's the Python file that I'm going to run on Heroku. But I need a few things more. First of all, I need to create another file, a new file, and that file will need to have the name proc file. Oh, spell it correctly, proc file. And in that proc file, and you can copy that and paste that from my website also here, you need to create a proc file. You need to add this line of code there. Zoom there, up, app, GUnicorn. By the way, I'm going to come back to this later on. We're going to have to use a library called GUnicorn, and this app here, app, refers to the name of my Python file. So if you were to rename your file, my Python file.py, then here you would have to write my Python file. But if you leave it just like the way I've done it, then that should be fine. So commit new file. And then lastly, you need to create a requirements.txt. And that requirements.txt is based on the whole idea that in Heroku there is no such thing as pandas yet, or there's no such thing as dash yet. So it needs to install those to create an environment which your Python file can actually run successfully. Now that is achieved by, and I'm going to go back to here because that's I've indicated here also, you're going to have to go to your command prompt and type in code that reads pip-rex requirements, this pip requirements, and then with a path to your file. Now you do that for once. First of all, the path to my file, where is my file located? And then it was the carbon emissions, this one here. So this path is the path I need to use, Control C. And then I go to my command prompt there, and I type in pip-rex, and then I use apostrophes, and the reason for that is that if you don't use apostrophes, you see there are some spaces there. Without the apostrophes, it would give me an error message. Now, if I run this, and this takes some time also, so I'll fast forward. Yeah. So now it says info successfully saved requirements file in that particular folder. So if I go back there now, then indeed it has created the requirements file. But if I open up that file, it's empty. This is not what I wanted. So there is an issue here, and the issue is that the piprex command looks for a Python file, and this here is an IPYNB, a notebook file in Jupyter, so it doesn't recognize it as such. So what you can do here is to copy and paste that file again. Yeah, so now I've got a copy there. Then I go back to my Jupyter environment. So the copy is here now, and I'm going to rename this one to py. Rename. Okay, so now I've got an actual Python file, but be careful. If I open up this file now, you'll see that it contains a whole lot more than just my Python script. Yeah, so it's added all sorts of code to it, and this is not what I want either. So that's why I made a copy, because if I go back to my original file now, I can now copy all of this there, Control C into that copied file, Control V, file, save, and now I'm going to run that code again. So I'm going to copy this code. By the way, the first time you're going to use piprex, you need to install it. Control C, Control V. If I run it now, it's going to give me a message to say there's already a file there, so I'm going to have to add an extra expression there that is force. It's going to overwrite the existing file already. Now I'm going to do that again. Yeah, there it is, successfully saved. Let's have a look now again at that folder. Now if you look in the requirements, you'll see indeed, oh, there is an indication. I'll open it up. There's an indication there of all the components that I need. And basically, this is based on the import expressions that you have. See that that contains all the necessary libraries. Now I can copy this. You can upload this into your repository directly. I can also just copy this into a new file in my GitHub there. So again, add file, create new file, so you can upload the file also. But there, I'm going to have to type requirements dot as a text file, and then add this in there. Now, the only thing I need to add here is gunicorn, because that gunicorn is necessary to create a server to run on. I hope I explained that correctly, but anyway, you need it. Then we're going to commit. So we end up with 3 files, and that's enough there. So we have the original Python file, we've got the proc file that indicates it needs to run on a particular gunicorn server, and in the requirements text it has the necessary libraries that we need to do all that. So here I'm going to go to Heroku, and I want to create a new app, and I'll call that, you can give the app name, carbon emissions region. Now let's call it a slider. Sometimes a name might be taken already, so this is available. You might also, if I just choose carbon, I guess carbon is not available, you see, so you need to choose something that is not used yet by somebody else before. Yeah, and it can't be too long either, also I noticed. So if your name is too long, then you can't even type anymore. This is the maximum number of letters you can use. So at some point you might have to use letters or digits possibly. Now that is sufficient, and I'm going to say create app. I'm not going to, well, I said it, but I'm going to click on the create app. And under deploy here, you'll find GitHub there, connect to GitHub. And that is wonderful, makes our life very easy. So if you need to, by the way, you need to create an account with Heroku. I didn't mention that explicitly, but I guess that speaks for itself. That's relatively easy to do. Now then, it connects to your. I'm just thinking out loud now. I think if you create an account, you can even attach it to your GitHub account, so it immediately recognizes your GitHub account. Now search. You can type in a name here also if you remember the name, but in my case, what did I do? Which is the one that I was using? Let's just quickly check. It's carbon emissions dash slider. Carbon emissions dash slider. It's this one here. So it might get confusing if you have more repositories. So now I click connect, and that then now it's connected. And then I simply click on deploy this particular branch, and then it will execute some code there. So it has detected the Python app. It's installing these requirements that I indicated. So this will take some time also. So after waiting a sufficient amount of time, and so like I said, this will take a minute or two, I suppose. And yeah, if it doesn't work the first time, then you're gonna have to do that again a couple of times. So it can become quite tedious. But let's have a look. Let's view this. So now you see a carbon emissions slider, and it's opening up the app. Let's hope yes, it's all there. Now, see if it works properly. Indeed, it changes, and if I use the slider here, it changes the graphs as we had done before, so it works perfectly well. And this means now you can at least share it on the site somewhere, also, or send somebody the link here. Excellent. Now, I do apologize for doing this in what may be perceived as a quite rushed manner, but I didn't want to make the video overly long. That also is tedious. So yeah, you're gonna have to play around with this yourself also, and I guess yeah, you're gonna run into trouble at some point, but there is help out there. So use all sorts of fora initially, and if you can't figure it out, then ask your peers or ask me also. It's I think great way to create to use Python to create these interactive dashboards. It's really state of the art. I think this is very neat, and there's many possibilities. Of course, there's also checkboxes and other core components that you can apply. They all come with their own specific code, and you're going to have to look at the support sites to see if you can get it to work. So your challenge: to find a data set, to manipulate it, and to create some graphs. And yeah, if you're up to it, try to create a dashboard also using Dash. I think that's a very interesting thing to master. Good luck, and I'll be hearing from you, I'm sure. Bye bye.